Good morning, students. Today we are going to learn our subject Maths, in which we are going to learn chapter number 7, that is triangle. Now, what is triangle? You have studied about triangles and their various properties in your earlier classes. Now, what is triangle? Triangle is a closed shape with three sides, or we can say that a closed figure formed by three intersecting lines is called a triangle. As you all know that triangle has three sides, three angles and three vertices as shown in the figure. From the figure we can say that here is triangle A, B and C, in which AB, BC and CA are the three sides. Then angle A, angle B and angle C are the three angles, and point A, B, C are the three vertices. So this is all about the triangle. Now you can see here are some triangular objects. Here it is a hanger which is in the shape of triangle. This is a piece of pizza, as you can see. It has also the shape of triangle, and this is the ice cream cone, in which you can see that it is the shape of triangle. Now come to the next topic, that is congruence of triangle. Now you will think, what is congruence? So I will say that you must have observed that two copies of your photographs of the same size are identical. Similarly, two bangles of the same size, two ATM cards issued by the same bank are also identical. You may recall that on placing a 1 rupee coin on another minted in the same year, they cover each other completely. So, do you remember what such figures are called? Indeed, they are called congruent figures. Means equal in all respects, or figures whose shape and size both are the same. So from these examples, we can say that congruent figures or congruent triangles are triangles that have the same size and shape. This means that the corresponding sides are equal and the corresponding angles are equal. As shown in the diagram, the corresponding sides of this is A is corresponding to D, B is corresponding to E and C is corresponding sides to the F. So the corresponding angles are also there. X is S, Y and T, Z and U. So this is the congruence of triangles which have the same shape and size. Congruent triangles do not have to be in same orientation or position. They only have to be identical in size and shape. Now, congruent figures. Now, here are the true triangles given. Triangle ABC and triangle PQ and R. Now, if we see triangles are congruent, then we need to check which parts are congruent. So basically what we need to check is if C is matching with P or Q or R. So we have to take a look at that. So angle A is matches with R, then B is matches with Q and C is matches with P, as you can see in the figure. So from this we can say that angle ABC and another one is angle PQR. So now angle C is corresponding to angle P because when we rotate it, the C is matching with the point P here. So those angles are equal. So we write as angle C is equals to angle P. Now angle B is matches with angle Q, as you can see. So we can write angle B is equals to angle Q like this, and angle A is matches with angle R. So we can write as angle A is equals to angle R. So these are called the corresponding angles because these are congruent triangles and these angles are equal to the corresponding angles. Now similarly, what about the side? So if you can see in the image, the sides are AB, that is correspond to sides QR. Similarly, side AC is correspond to side PR and side BC is correspond to side PQ. So now we see that sides of triangle ABC coincides with side of triangular PQR. So from this we can say that triangle ABC is congruent to triangle RQ and P, and this is called CPCTC, that is corresponding parts of congruent triangles are congruent. It means if two triangles are congruent, then all the sides and all the angles of one triangle are equal to the corresponding sides and angles of the other triangle. That means CPCTC. So this is all about congruence of triangle. Now our next topic is criteria for congruence of circle. Now if two triangles are congruent when they are equal in all respects. So in the previous slide we have discussed congruent triangles have exactly the same side and exactly the same angles. So from this we can say that there are 5 methods or criteria to find if two triangles are congruent or not. So criteria for congruence of triangle have 5 criteria. So first one is SS congruence rules, in which all the sides of both the triangles are congruent but both the triangles are equal. And second, it is SAS congruence rule, that is side angle side, in that any two sides and the included angle are congruent for both the triangle. So they are congruent. Third one is AAS congruence rule, angle angle side rule. So in that two triangles are congruent when any two pairs of angles and corresponding sides are equal. Fourth one is ASA congruence rule, that is angle side angle rule. In that two angles and the included sides are equal for two triangles, then both the triangles are congruent. And last one is RHS congruence rule. In a right triangle, when the hypotenuse and any one side is equal, so both the triangles are congruent. Now we will learn this all in detail, one by one. Now let us discuss one by one. And the first one is SAS congruence rule. First, here we know that the angle must be included between the two sides given. Now we will understand what included means in a little bit. So first, let us understand what the condition tells us. So the first criteria is SAS congruence, that is side angle side congruence rules. So what the condition tell us, that two triangles are congruent if two sides and the included angle of one triangle are equal to the two sides and the included angle of the other triangle. Now to understand this, first we have draw triangle ABC and triangle PQR. So first, in that triangle A, B and C, we have given side AB which is 2 centimeter and side BC which is 4 centimeter, and angle A, B and C is 50 degree. Note that in that the angle is included between the two sides. The two sides are AB and BC, in which the angle B is included. And in the similar way, we have triangle PQ and R. In that triangle PQR, we have side PQ which is equal to 2 centimeter and side QR which is equal to 4 centimeter, and here is the angle Q which is 50 degree. So from this we can say that the triangle which is formed will be exactly like triangle A, B and C. If we take this triangle PQR over to this one, so they will overlap exactly. So from this we can say that triangle ABC is congruent to triangle PQR. So this is about the SAS congruence rule. We always remember that two sides and included angles, here is included angles in both the diagram, or we can say in a triangle, then the two triangles are turned to the congruent, and this is what we call the SAS, that is side angle side congruence. So SAS congruence states that two sides and the included angle of a triangle are equal to the corresponding sides and the included angle of the another triangles. So the two triangles are congruent to each other. So this is about the first criteria, SAS congruence rule. Now According to the SAS congruence rule, we will solve some example. Here you can see the figure. So here is two triangles is formed. Triangle AOD and triangle BOC. So in that we can see that OA is equals to OB and OD is equals to OC. That is already given in our question. So what we have to do? We have to show that triangle AOD is congruent to triangle BOC, and also we have to prove that AD is perpendicular to BC. So now let us see the solution. Now you may have observed that in triangle AOD and in triangle BOC, OA is equals to OB and OD is equals to OC, that is already given to us. Also angle AOD and angle BOC, they form a vertically opposite angles. So we can say that angle AOD is equals to angle BOC. So these both are the vertically opposite angles, and by the SAS congruence rule, we have proved that angle AOD is congruent to angle BOC by the side angle side congruence rule. Now we have proved triangle AOD is congruent to angle BOC. Now we have to prove another one, that is AD is perpendicular to BC. For that, in congruent triangles AOD and BOC, the other corresponding angles are also equal. So angle OAD is equals to angle OBC, and this both form a pair of alternate angles for line segment AD and line segment BC. Therefore, we prove AD is perpendicular to BC. Now, come to our next example. That is, AB is a line segment and line L is its perpendicular bisector. As you can see in the image, here is a triangle in which AB is a line segment and L, here L is drawn, that is perpendicular bisector. So if a point P lies on L, show that P is equidistant from A and B. Now suppose line L is perpendicular to AB and passes through the point C, which is the midpoint of AB. So you have to show that PA is equals to PB. For that, first we have to consider that there are two triangles. As you can see, if you cut this line, so we get two triangles, triangle PCA and triangle PCB. So we have C in the midpoint of AB. So from this we get AC and BC, that is equal to each other. So we can write this as AC is equals to BC. So from this we can say that there are two triangles PCA and triangle PCB which have 90 degree. That is given in our question. So we can say that angle PCA is equals to 90 degree and angle PCB is also equals to 90 degree. So we can write as PCA is equals to angle PCB and PC is equals to PC because point C is bisector at point L. So from this we can say that PC is common to both the triangle PCA and triangle PCB. So from this we can say that they are both the corresponding angles by SAS rules, that is side angle, side angle, side rule. So from this, hence we prove that angle PCA is congruent to angle triangle PCB. Now, so we have proved that PA is P equals to PB. So as we have already said that they are the corresponding sides of the congruent triangles. Hence we have proved P is the equidistance from point A and point B. Thank you.